Hello my people, I hope we're doing well. This video is going to be on inscribed shapes, okay? And we are going to start with this one. Now it says a rectangle is inscribed between the parabolas y is equal to 4x squared and y is equal to 30 minus x squared. What is the maximum area of that rectangle? Okay. So let's go ahead and just draw a random rectangle in here just to get us started so we can start labeling stuff. Okay. And then, okay, that's good. Now remember, when it's on the Cartesian plane, we need to be careful to remember that that is x and that is y. That means that the area is not x times y, the area is 2x times y. Okay. Now, the distance x is fine enough. The height is going to be basically the difference between those. So my y distance is going to be 30 minus x squared minus 4x squared, which is 30 minus 5x squared. And of course you can factor the 5 out if you want. 6 minus x squared. That means that my area with respect to x is going to be 10x 6 minus x squared. Now you didn't really have to factor that out, but you know, it's not bad if you did. And basically I would just distribute the x in here to make it negative x cubed plus 6x. Now the reason you're not doing the 10 is because you really don't have to. It's the coefficient. It comes along for the ride. And so when we take the derivative of this, like I said, it comes along for the ride and we get negative 3x squared plus 6. That can be, of course, further simplified by pulling out a negative 3 as a factor. And it winds up being x squared minus 2. Now it ought to be pretty easy to tell that from here, this is going to give us two critical points. X is equal to plus or minus root 2. And we should know, of course, so those are our critical values. And that, of course, is 1.414. Now, that means that, and of course, if we're asked to justify that, we can go ahead and we can do it either in terms of a first derivative sign chart using the first derivative test, or you can basically figure out what that point of intersection is right there, because x has a interval, a domain of 0 to whatever that is. Okay. And basically, if you do that, I mean, you could figure that out really quickly. 30 minus x squared, when is it equal to 4x squared? Okay. And you get 30 minus 5x squared, or, you know, x squared minus 6. So x is equal to plus or minus root 6. Now, plus or minus root 6 shouldn't be all that hard. Remember, we've already taken root 6 over 2. And this is 2.450. So x is approximately plus or minus 2.450. So 2.450 is, so basically you can check the endpoints and you can check the critical value and figure out which one is the maximum area. But of course, common sense should tell you that if x is 0, you have a rectangle of 0 width and therefore an area of 0. And if you have x all the way out here, you have you have a rectangle of 0 height. So obviously the critical value which falls within that interval is going to give you your maximum volume. But you are actually asked, maximum area. You are not asked for the value that gives you the maximum area. You are actually asked, what is the maximum area? So we need to go ahead and go back to the original. We need to evaluate it at root 2, and you can do it in this form or in this form. I suggest this form. 10 root 2, 6 minus 2, so you get 40 times root 2, or approximately 56.569. And so you would say the max area is 56.569, and you're done. Now, we're going to go on to one that is familiar to us, basically in preparation for one that is less so. Okay, so a rectangle is inscribed in a right triangle having side lengths in inches of 6, 8, and 10. Find the dimensions of the rectangle with greatest area, assuming the rectangle's position to be flush against the leg of the triangle. So we'll go ahead and draw this, and then we'll draw this, and we have our rectangle. And what we need to do is we just need to start labeling this bad boy. You know that this whole thing right here is 6. This whole thing right here is 8. And of course the whole hypotenuse is 10. That's really not going to come in as an issue. We'll call this x and this y. This is also x. This is also y. If this is x, then this is 6 minus x. And if this is y, then this is 8 minus y. Now, I know that the area of the rectangle is going to be x times y. But again, I have a problem. I have 3 variables. So I need to basically set up a proportion, because remember that this gives you similar right triangles. And let's use the big triangle measurements together with one of the small ones. I want to do that because the big triangle measurements is 2 constants, right? And we want to minimize the number of variables we're playing with. So we have 6 is to 8, and that doesn't matter. You can choose this triangle, you can choose this triangle. Let's go with this one up here. 6 is to 8 as x is to 8 minus y. We get 48 minus 6y is equal to 8x. We get negative 6y is equal to 8x minus 48. And therefore y is equal to negative 4/3 x plus 8. Now that is going to transform this into, it's not going to be a anymore, it's going to be a of x, because it's going to be a function of one other variable. And you get x times y, but our y value has it in terms of x. So we get negative 4/3 x squared plus 8x. Now, from there, we're going to go ahead and differentiate as we have in the past, and we have a prime of x is equal to negative 8/3 x plus 8. When we set that equal to 0, we're going to get 8/3 x is equal to 8. The 8's cancel, obviously, and x is equal to 3. If x is equal to 3, then y is going to be equal to, well, we can go ahead and just plug it right back into here. If x is 3, you get negative 4 plus 8, you get 4, okay? So the dimensions are 3 and 4. Now, we've done one like that before, so that, like I said, was just prelude to this one. The rectangle is to be inscribed in a right triangle having sides of length, and it's the same big triangle. Find the dimensions of the rectangle with the greatest area, assuming the rectangle is positioned to be flush against the hypotenuse. Now this is a different animal altogether, okay? So let's go ahead and let's set this up. So I'm going to go ahead and turn it this way real quick in order to get sort of a nice sort of rectangle in here, because it's going to look something like that. Now we still do have similar right triangles in here, but we have to be careful because some of them are turned this way and some of them are turned the other, right? These two have this right here as their hypotenuse, short leg, long leg, hypotenuse, but this one has short leg, long leg, hypotenuse, and this one has short leg, long leg, hypotenuse. So they're all kind of turned around a little bit. But let's go ahead and let's talk, this is still 6, so this is x, and this is 6 minus x. This is y, and this is 8 minus y. Okay. Now, what we're going to do is we're going to need to and I'm going to flip this. No, let's not flip it over, but let's go ahead and call this length A. So that's also A. We're going to call this B, and that's also B, which means that my area on this one is A times B. Now, I still have proportions that I can play with, which means that I can actually do something like 8 minus y over b, and be careful, that's hypotenuse over short leg, is equal to hypotenuse of the big triangle is actually going to come into play here, 10 over 6, which of course can be reduced to 5/3. Okay. Now, we're going to go ahead and what we have is the gosh, lost my place. Hold on just a second. Okay. Now, I need basically the a times b, so I need a or b in terms of x or y. Let's go ahead and use this proportion to find b. So we have 3 times 8 minus y is equal to 5b, and therefore b is equal to, let's call it 3/5 8 minus y. Now, we know also that a is equal to the square root of x squared plus y squared, because look at this small triangle right here. Just simple Pythagorean theorem tells you what a is. Well, that doesn't help me a whole lot, and the reason that that doesn't help me a whole lot is because if I plug these two things in for a and b, I still have it in terms of two variables. But I'm going to go ahead and figure out how to get rid of that y right there, okay? And I'm basically going to use another proportion. And you know, there may be an easier way to do this, but let's just go ahead and keep going with this one. So let's go ahead and remember that a is the square root of x squared plus y squared. So let's do hypotenuse over short leg. Hypotenuse over short leg, well, we know that that's 5/3. We've already used that. And so basically what we have is we have 3 times x squared plus y squared is equal to 5x. We're going to go ahead and square both sides. Okay, and when we do that, we're going to go ahead and get 9y squared is equal to 16x squared, or basically you can say y squared is equal to 16/9 x squared, or x squared is equal to 9/16 y squared. But I want to get rid of the x in here, don't I? I want to get rid of the x because this one's already in terms of y. So if I use this right here for this x squared, then a is going to be equal to 9/16 y squared. This is going to be 16/16 y squared, and that together is going to be the square root of 25 over 16 y squared. So now I have a and b both in terms of y. A little more complicated to do it with the rectangle laying on the hypotenuse, but I wanted to stress that's still possible, right? So the area in terms of y is going to be what? Well, it's going to be, we're going to go ahead and simplify this right here, okay? This is going to wind up being 5/4 y. And the reason we can do that is because we don't have to deal with plus or minus. This is geometry, right? And so what we have here is 3/5 times 8 minus y times 5/4 y, which basically those numbers, the 5's cancel out. I'm going to get 3/4 y, 8 minus y. And then, you know, that becomes negative 3/4 y squared plus 6y excuse me. Yeah, that's right. And therefore, a prime is going to be negative 3/2 y plus 6. Okay, you can go ahead and you can basically set it equal to 0, and you're going to get 3/2 y is equal to 6, and therefore y is equal to 2/3 of 6, which is, of course, 4. All right. Now, once you have the y is equal to 4, you can find your a and your b, because both your a and your b are in terms of y. Okay, that means from here you're going to get a is equal to 5, because a is 5/4 of 4, and then you're going to get 3/5 of 4 as well, so 12/5. Okay, which of course is going to give us an area of 12. Now, not the cleanest and easiest one in the world. You had to do a little bit of tinkering, a little bit more tinkering than the other one, but certainly doable. And another basically potential way of asking a question on inscribed shapes. We're going to bring this video to a close. If you have any questions, as always, shoot me an email. Bye.